Okay, so welcome back for part 2 of significant figures. We're gonna recap just a little bit about the rules, and then we're gonna look at how we're gonna use them in calculations. So there are times when we don't want to limit ourselves based on significant figures. We can ignore these rules that we've just gone over. There are really only 2 cases where we can do that. The first one is when we're counting things. So if we count, say, 3 apples, then we're not going to call that one significant figure, right? There are definitely 3 apples. We are exactly sure about that. That's an exact number. So we don't need to use significant figure rules when we know that the number is exact. Likewise, when we have definitions provided to us, so if 1 foot equals 12 inches, we take that to be an exact definition. Right, so counting numbers, whole counting numbers are exact definitions. We don't want to think about significant figures. We just take those numbers to be true, and we won't count the significance of each digit. Now, when numbers are involved in scientific notation, we're going to talk more about scientific notation in lecture, then every digit is significant in scientific notation. So if I look at 2.460, if I apply the rules to this, right, and I kind of ignore this base 10 part, I mean, it's important, but not when we're counting significant digits. All the rules still apply. Rule 1 told us that all non-zero digits, so 2, 4, and 6, those are all significant. And then there's that magic 0. He's after the decimal. He's at the end of a number. So all 4 of those are significant digits. Typically, though, the rule is if you're in scientific notation, right, if you're in base 10, then everything that comes before that base 10 part is significant. So here there are 4, so we'll take that to mean 4 significant figures. The rules, though, still apply. So you can either use, this is essentially like a shortcut, or you can calculate it out the long way and use all your rules. Anything that is not an exact counting number, a definition, or scientific notation, right? Everything else, we're going to use the 3 rules that we learned in the last video, right? Those 3 rules are simple ways to essentially just figure out if zeros are significant figures or if they're placeholders. That's all those rules help us do. And once you all firmly understand what it means to be a significant 0 versus what it means to be a placeholder 0, then you won't have to rely on the rules quite so stringently. You'll be able to internalize the process and look at a number and figure it out. Okay, so if we're going to use significant figure rules in mathematical operations, addition and subtraction are different than multiplication and division. So in addition, right, we're still going to add, it's still math. We're going to look at where that decimal lies. We're going to do math to the whole numbers. We're going to do math to the decimal portions. It's just that the significance is going to change. So when you're adding and subtracting, your whole number, whatever it comes out to be, right, your whole number is going to be significant. So you got to add that up. I don't know, I'm over red, so now I like blue. So we can add that up and nothing's going to happen. They're all those digits that come out of the whole number place are going to be significant. The place where we're not going to be able to always assure significance is in the decimal portion of the number. So if we think of all these values as being measurements, some measurements are stronger than others, right? So this, whoever measured this measured 1 place past the decimal. Whoever measured this measured 2 places past the decimal. The further past the decimal we go, the more certain the measurement, right? So whoever measured 12 wasn't very certain about it, right? This is the least certain measurement because there's the smallest amount of information. Okay, well, you guys know what I mean. Certain. Okay. So this guy's the least certain. He gives us no information behind the invisible decimal. So when we're adding up numbers, the number that we're allowed to produce as an answer will be limited by the number with the least significance after the decimal, right? So this guy has 1 significant figure after the decimal. This guy has 0 significant figures after the decimal. This guy has 2. So it's this weak measurement here with the 12 that's going to limit what we're allowed to present after we do this math. So when we do the math, we see that this comes out to be 24.83. If we were mathematicians, right, if this was pre-calc class, we'd be done. But it's not. We have to evaluate these numbers for certainty and reliability. I cannot be this certain of this measurement because I'm not that certain when I measure that 12 or when I measured that 5.1. So we can produce a number from these from this calculation. It's just that our answer can only be as significant or as reliable as our worst measurement. So that means I cannot put any places past my decimal. So now that I know I have to round, essentially, I have to round this number, I'm going to use rounding rules. So this 8, of course, is big. That's going to round that 4 to a 5. And so I can only call this 25. I cannot put anything past the decimal because I'm limited by my least reliable value. I could, if I felt so inclined, write 25.0. We don't do that in math class. We don't just put a decimal for no reason. But in chemistry, when you put a decimal, it's saying, I mean exactly 25. Right? And we'll talk a little bit more about that in class when we do some examples together. So that's the way we're going to look at every addition and subtraction calculation that we do in class. We're going to limit ourselves by our weakest measurement. The same is essentially true in multiplication and division, but because when we multiply, right, just like the algorithm that we use when we multiply numbers, we multiply decimals by whole numbers, right, and whole numbers by decimals. We use all the digits and we multiply everybody by everybody to get our final answer. We can't just keep the whole numbers and the decimals separate. We have to evaluate the entire number. So we're going to determine the significant figures, right, in each of the numbers we're multiplying or dividing, and that's going to predict what we can do or what we can present in our final answer. So, of course, 38.65 has 4 significant figures. 105.93 has a trapped 0, but that gives us 5 significant figures. Just like in addition and subtraction, we are limited by our least certain measurement. Limited by least certain. So in this case, right, that would be our least certain measurement. We only have 4 significant figures. We can only show 4 places of significance in our answer. So we got to take this number. We need to reduce it to 4 sig figs. So again, we're going to just use rounding, right? All the rounding rules still apply. 1 is small, so he's not going to be able to bump that 4 up. So I will report 4,094 as my final answer. Again, I could put that decimal. Doesn't really do anything, doesn't change anything, but it means I mean it exactly. If you put down the number that your calculator shows you, again, that would be fine in math class, but now we're adding a layer of inference. So we're trying to help people out there in the scientific world understand what we mean regarding the certainty or the reliability of a number. We can only be as certain as our least reliable number. So every time you give me an answer on a homework or a worksheet or an exam or quiz, I will always be looking for you to follow these calculation significant figure rules. Again, we're going to go over more of this in class. I hope it was helpful. Check out the book if you have more questions, and of course, bring any confusion or concerns you have to lecture, and we can talk about them as a class. See you guys then.